Hello, algebra scholars. This is skill 3.3, which is defining quadratic analysis terms. So this is going to help us with the special types of functions eventually that we're going to get to, because you are going to see things like x-intercepts, roots, and zeros happen continuously, even in things like exponential and rational functions. So we might as well review into quadratic functions as well. And you'll see the axis of symmetry is conveniently given by the x equals negative b over 2a. And the minimum or maximum value is taking that axis of symmetry and then plugging it into the equation to find the y value. We can also, just by reading the a in kind of that general form of the quadratic, ax squared plus bx plus c. We can also kind of get an idea about what direction and how wide and narrow the parabola is going to be. And we can also find the y-intercepts by just looking at that c number. So let's take a look here. This is a basic question where you have a graph, and your job is going to be to do things like find the roots and zeros first. So roots, zeros, these just basically mean x-intercepts. And we'll just put in coordinate form. So we have 3, 0 and 7, 0. Obviously, if I didn't give you the graph, you would just factor the equation and set it equal to 0. The axis of symmetry is given by where the x coordinate of your vertex. So I just draw that vertical line. And in this case, it is x equals to 5. And that maximum or minimum, in this case, it's a minimum at and we'll just put the coordinate here. So we'll say that that's going to be 5, -4. And then the a value, one thing we know for sure is that it is positive. And another thing that we can kind of tell is that since we are just going up by 1, and then going up by like 3 more, it's kind of a standard width. So that a value is going to be +1. So now let's actually do an analysis and actually create a graph. But first, I could actually not give you a graph and you could figure out what the maximum and minimum is. So to find the axis of symmetry, you would do negative b over 2a. So that's going to be a -3 over 2 times -3. So that's exactly 1/2. Or we could just call this like 0.5 as well. Either one is fine. And it is a x equals type of scenario. And then if I want to find the y coordinate, what I could do is I could plug in the 0.5. So I get -3 times 0.5 squared plus 3 times 0.5 minus 3. And obviously you want to get a calculator for this. You could even just go to your Delta Math Scientific calculator and enter it in immediately. But 0.5 squared is 0.25. times -3. So that's going to be negative 0.75 plus 1.5 minus 3. So that means that our minimum value, or not minimum, it's actually going to be maximum, since it's an up, kind of a downward facing. Our maximum value would be negative 2.25. So let's actually create a graph now. We could actually pretty much without a graphing calculator figure out everything that we need. First thing that I would do is I would find out what my axis of symmetry is. So this is x equals to opposite b over 2a. So a negative of a -6 is just going to be positive 6 over 2 times 1. And then I'm going to just find that 3. And this line is going to cut my parabola exactly in half. And then I can find my y value by just plugging in the 3. So I have 3 squared minus 6 times 3 plus 5. So that's 9 minus 18 plus 5. So that y value is going to be -4. So our vertex is at 3, -4. All right, then what we're going to do is we're going to think about the next thing. I think the easiest thing to do is look for that y-intercept. So our y-intercept is at +5. And I'll give you a little secret here. This +5 is 3 units to the left. So if I go 3 units to the right of that axis of symmetry, I can actually come up with a third point, and I can get a pretty good idea about where that parabola is going to be. But I may want to just do the ACB chart and factor. So A times C in this case is 5. And I want 2 numbers that add to -6 and multiply to 5. And those 2 numbers would be -5 and positive -1. So this would be y equals to x squared minus 5x minus 1x plus 5. And I'm just going to group these 2 terms together. I got an x in common from the first 2. I got a -1 in common for the second 2. So I'm going to write x times x minus 5 minus 1 times x minus 5. And if you just take each factor and set it equal to 0, then you can find those x-intercepts. Oop. Oop. And there we go. So now I can actually get almost exactly the graph, even just by simply finding the factoring, the axis of symmetry and the y-intercept. And I can get like a perfect graph without a graphing calculator at all. And some of these terms like y-intercepts and x-intercepts and vertex you are going to see in other types of functions. So if we can kind of see this in quadratics and apply them to other types of functions, that's going to make graphing other types of functions a lot easier.